This conference will now be recorded.
99.73% will be between 3 sigma. Okay, now 95% of sample fall with 1.96 standard error, and 99% of sample will fall with 2.58 of standard error. Okay, so this what is this 1.96 standard error is? This is nothing but a standard deviation that I am getting from my data set. Okay, now in the confidence interval, okay, we have discussed what is population, what is sample. A point estimate of a parameter is the value of a statistic that estimate the value of the parameter. This is sample mean. Okay, what does the confidence interval estimate? It estimate of a parameter consists of an interval of a number along with a probability that interval contain the unknown parameter. Okay, so the language is bit difficult to understand here, so let me make it as a simple way. What confidence interval normally estimate that the calculated coefficient that you have will lies between this particular range with this percent of the confidence level. By confidence level I mean that out of confidence level you can think it as a probability. Okay, so if I am telling you that I am following a confidence interval of 95%, which means 95% time when you take a value from this particular population you will get it in this particular range. If I'm defining you some range, if I'm talking about a 99% confidence interval, which means out of 100 when you take a sample 99 times, you will get it in this particular range. And that's where the six sigma concepts come into the picture. So when you divide 1 million, and if you want to find a 99.73 will be non-defective out of 1 million, so one would be defective in a million. So that concept comes from this particular thing, this normal distribution graph. So what is six sigma is more the, so when you follow one sigma approach in this, if you follow a sigma approach, so in that case what you are getting only 68.27 time population into your particular range, which means around 32% time you are not able to get the number in a particular range, right? Similarly, in a 2 sigma you are getting 95, so which means the 2 sigma approach is um, much more correct than a 1 sigma approach. And similarly the 3 sigma approach is also more correct than a 2 sigma approach. So whenever you are doing a regression or anything, today's we always used to follow a 99% confidence interval, which means that whenever we predict the thing 99% time, 99.73% time, it would fall under the same range. Okay, 90%, 95% level of confidence would mean that if 100 confidence interval were constructed is based on the different sample from the same population, we would expect 95% of the interval to contain the population mean. The same thing another way, the confidence interval we have discussed now. Okay, so this is the formula to calculate the confidence interval range. This is the formula. So normally when you plot a normal distribution, it has, there is one concept. So you must be aware about the logarithmic table that you have, right? You must be aware about, there is something called a logarithmic table which has the all the log value corresponding to all the numbers. Similarly you have a z table. When you type it on a Google, there's something called z table. Under the z table you have something called confidence interval. So let's say if you want to have a confidence interval of 0.1 95% confidence interval, which mean alpha will become 0.05. So there is an z table corresponding to z 0.05 divided by 2, which is equal to z 0.025. So there is a z table corresponding to this, which will tell you a value of that particular number. So this normal distribution normally follows, has a table that is known as a z table, which is normally used to determine the value. Now let's say this is the question that you have. The question is, the national loan the national student loan survey collected data about the amount of money that borrower owes. Okay, the the survey select a random sample of 1280 borrowers. So the number of sample that I have is, I have around 1280 sample. So my end number of sample that I have is equal to 1280. Now the mean debt of the selected borrowers was $18,900 and the standard deviation is 49,000. So I know that my mean is equal to $18,900. Similarly, I know the standard deviation is equal to $49,000. Okay, what I need to find, I need to find a 95% of the mean debt for all the borrowers. What I want to find, I want to find a confidence interval range at a 95% confidence interval. Okay, so I have the number of sample that is 1280. I have the mean, I have a standard deviation. I want to find a range of the mean with a confidence interval of 95%. So how we'll do that? Okay, so how we will calculate this? So to calculate a confidence interval, we have this formula which is equal to mean plus minus. We need to check a standard z table which correspond to sigma divided by under root n. So first of all, what we need to do is we need to calculate standard deviation divided by under root of mean. So we need to calculate, let me open a paint over here. So what we need to calculate, we have a mu, we have a sigma, we have n. Okay, we have a mu, we have a sigma, we have n. So which means that I know the mu, I know what is mu is, I know the my standard deviation, I know that n. I need to find a range, a confidence interval range with a 95% confidence interval. Okay, so what I will do is I have a formula to find a range which is equal to mean plus minus z. There is a z table with alpha by 2 into sigma divided by underscore n. So I know this sigma value, I know this n. I will calculate a z value corresponding to this particular number at this particular confidence interval. So my confidence interval will become alpha will be equal to 0.05. Alpha will be equal to 0.05. So you need to find a z table corresponding to 0.025 into this sigma by n. So when you see a z table, you'll get this number. Z table with a base of 0.025, with this number you will get some number. Once you get that number, once you have, what you need to do first, you need to do addition, and then you need to do the subtraction. Once you are done with this, you will get a range of this sample with a 95% confidence interval. Am I clear?
Yeah, why this alpha value has become 0.05? This is not clear to me. Like we are telling 95% interval.
So by 95%, it means alpha is equal to 0.05. By 99, it means the formula of alpha is simply 100 minus the confidence interval. Alpha is 100 minus confidence interval. Simple. Okay. The formula of alpha is equal to 100 minus confidence interval.
Yeah.
Okay. So you guys understand how we calculate a confidence interval, how we calculate a range. Okay. Any questions? Any questions till now? Yatendra, do you have any doubts? Sanjay, Yatendra?
No, I'm very much clear.
Okay, thanks, Yatendra.
I
Anything?
think Hari's question when he was asking 0.05, because probability is from 0 to 1. So when you are looking at that 95%, you are looking at from 0 to 1, that means it's 0.95. And the other one, it will be 0.05. So that's how it's coming.
Yeah. Sanjay, you have written no, we have studied, which means I don't understand.
We had some class with Shrikant, so that's what he's saying. That's why we are saying we are clear on this.
Okay. That's great. Okay, so this is the confidence interval that we have discussed. Okay. So the construct of the confidence interval for the population means depend upon this three factor. The first one is the point estimate of the population. By point estimate, I means the mean that we have calculated out of my sample. So this is the first construct. The second one is the level of confidence that you want, whether you want it at a 95% confidence interval or a 99% confidence interval. And the third thing is, what is the standard deviation of the sample? Okay, so this confidence interval is mainly construct based on this particular three factor. Okay. Okay, we have mean, standard deviation. Okay. So this is the meaning of, similarly, the meaning of 95% sample means of the interval. Okay. Okay, let me talk about this. Okay, so let's talk about the distribution of the sample mean. Okay. So what we have to do is, in this case, I have some example to make you understand how the distribution of the sample mean varies will affect the result of the confidence interval. So the different sample mean give a different means. Different sample has given me a different mean, but the distribution of sample mean is normal. Okay, so the condition that I have written is, sorry, for the large sample size. If you have a small sample size, you will not get a proper normal distribution plot. Okay, so the distribution of the sample mean is, let's say when you have a number of sample that is 300, you are getting a graph like this, which has the mean of 5.12 and the standard deviation of 2.57. Once you increase the number of sample, the mean will not change. I repeat, the mean will not change, because I have already explained you this mean is something that is a point of estimate. This is point estimate of the population, so it would not vary much. But the standard deviation, you will see a huge jump in the standard deviation. So since you have increased the number of sample from 300 to 2601, your standard deviation has decreased. Okay. Now, the distribution is more compact than a population. Let's talk about the sample mean. Why the distribution of sample mean are more compact than a population? Yeah, because again, because of the sample size. Yeah. So right now, what we have discussed that if you increase the number of sample, the standard deviation will decrease. You will see a huge jump in the standard deviation. The reason behind that, because we follow a formula in which we calculate standard deviation that is equal to which is equal to the standard deviation of the sample divided by the number of the sample. So we do the square root of this. That is why we see, if you increase the number of sample, we'll see a huge drop in the standard deviation. Okay. This is the meaning of 95% confidence interval we have discussed. This is 95% confidence interval. Okay. Okay. Yeah. So let's solve this simple problem. This is the central limit theorem problem. Okay. So let's say there is one company which make a 2.4 liter V6 engine. Okay. The company engineer believes that the engine delivers an average power of 220 horsepower. So what you want, you always want to have an average power of 220 horse HP. Okay. And the standard deviation that you want to and the standard deviation that is there in the power delivery is 15 horsepower. Okay. So you have, let's say you are a manufacturer and you manufacture a engine which is giving you an average power of 220 with a standard deviation of 15. Okay. Let's say a potential buyer intend to sample 100 engine, right? So let's say a buyer comes and he want to take a sample of 100 engines. Okay. What is the probability that sample mean will be less than 217? Okay. So do you understand the question? So question is, you have manufactured one product under which you have quoted that the average power of this engine is 220 with a standard deviation of 15. But there is a buyer who comes who has mentioned you that their requirement is they don't want that the horsepower should be less than 217. So they are okay with uh, till 2017 horsepower, but they are not okay with the horsepower less than 217. So if they have taken 100 sample, you need to calculate what is the probability that a sample mean will be less than 217 horsepower. So this is very interesting question. So what you have? So in this case, you have quoted that the mean of your population that you have created is 220, right? And the standard deviation is 15. Okay. Buyer want, now you want to calculate the probability where the mean is less than 217, where the mean is less than 217. So when you plot this in a normal distribution, what you will get? You will get this as a mu. This is your 220, and this is something normal distribution that you have. You'll have, let's say, your value something 217. 217 will come somewhere around this. So you want to calculate the probability from your sample if you get this number. So you want to calculate the probability of this particular range, right? How you will do that? So now you want to what is the probability that sample mean will be less than 217? So what you have done in this case, so first of all you calculate, you have a formula that you know, uh, you have a formula. What you will calculate, you will calculate a z value which is equal to x minus mu by sigma divided by under root n. This is your z value. So you will calculate a z value over here which is equal to x minus mu divided by sigma divided by under root n. So you have, you will so what would be your x is, your x is 217, your mu is 220, and your standard deviation is 15. Okay, and your sample size is n because the buyer has taken only 100 sample. So your sample size is 100. So you have calculated this x minus mu divided by sigma into n, which is equal to z, which after the calculation you are getting it as -2. You are getting it as a -2. Now based on the z value, you will calculate what is the probability that the z value will be less than -2. And again, based on the probability table, you will get the value corresponding to this, which is equal to 0.00228. Now this is the mathematical calculation, this is the mathematical formula for this. Now when you do a regression, when you have a regression coefficient, you will have a p-value corresponding to that. Okay, which will tell you whether the difference is significant or not, which will simply tell you whether the difference is significant or not. Let's say when you are comparing two variable x1 and x2, you will get some p-value, which means that there is a significant difference between this x1 and x2. Okay, so this is one of, again, the important simple question on the central limit theorem. Okay, let's talk about other questions. We have some more questions on this. So in this question, what is there in the above sample? Let's say I have a sample of 60 students, 20% of them lived within 2.5 kilometers of the school. Find the 95% confidence interval for the proportion of student from the school who live within the 2.5 kilometer of the school. So we need to find a confidence interval again for the proportion of the student who lives close to the school, which means I need to find a confidence interval with the mean of 2.5, and a confidence interval is 95%, and the number of sample is 60. Number of sample is 60, and the probability distribution is 0.2 over here. So the probability distribution is 0.2 over here, right? Makes sense or not, right? Any, do you understand this question, or do you have any doubt in the previous question? So do you understand what the question is telling you in this case? This is also very much similar to the previous one. Again, you need to find a confidence interval, but in this case you don't have a standard deviation. Instead of a standard deviation, you have a probability. By using that particular probability with a z table, you can simply calculate a confidence interval, and once you got a confidence interval, you will simply add or subtract it to get a value. Okay, so I'd not go into much detail on this solution. uh, okay, let us talk about. Okay, so right now I think you're okay with the confidence interval. How do you calculate the confidence interval, and what is the importance of the confidence interval? Let's talk about hypothesis. Do you know what is hypothesis in the stats? How many do you have this session with Srikanth on this hypothesis? Okay, so you have this session with all of you have this session, right, Sanjay? Or you have attended in some other batch? Yatin, do you have this session with Srikanth?
Yes, yes, I wrote it for you. That yeah, we had hypothesis. Vishekant.
So you must be aware about what is null hypothesis and alternate hypothesis.
Yeah, correct, correct. We are.
Do you need to cover this thing again? Type 1, type 2 error. Are you aware of this?
I'm aware of that. I'm sure in our class was Sanjay
Yeah, so
Waqar was there, but
yeah,
I
please
don't know
tell
about.
me. Yeah, please tell me from the attendees that do you want to cover this hypothesis or not? Because most of you have attended this session with Srikanth, right? So do you want to cover this hypothesis and what is type 1, type 2 error? Others like Arav, Divya, Rakesh, do you want to cover this? Arun, you have not attend. Hari, some of us not attend yet. Arun, do you have attend this hypothesis or not? No. Okay, Divya has also not attend this hypothesis. Okay, so we'll quickly. Okay, there are lots of attendee who have not attended this hypothesis section. Okay, so Yatendra and Sanjay, who all have attended, just a quick revision for you. What is hypothesis is in the stats. What we do is we will have a null hypothesis and alternate hypothesis. Okay, so whatever the statement that we want to prove, okay, we always used to keep it as a null hypothesis. Let's say if I want to prove that the mean of this particular sample is 25, so I will keep it as a null hypothesis, and the null hypothesis we denote it as a h naught. Okay, so my null hypothesis would be, let's say my what when I'm doing some research and I my I want to find that okay the mean is equal to 25 or not. So my null hypothesis will be mean is equal to 25. So this is the statement that we assume and then we prove this statement. So that is a null hypothesis. And the alternate hypothesis, what we do, alternate hypothesis is something where we assume that mean is not equal to this, or mean is greater than this, or mean is less than this. So statement that we want to prove is comes under the null hypothesis. A statement which will support to reject the null hypothesis will come under the alternate hypothesis. Okay, so let's take an example, simple example, that I want to predict that okay the mean of this particular population or sample has is 25 or not. So in this case my null hypothesis will become x is equal to 25, and my alternate hypothesis will become x is not equal to 25, or x is greater than or less than 25. Okay, so now one questions to Yatendra. You guys have already covered the null hypothesis or alternate hypothesis. Under which case alternate hypothesis will have value like this, mean is not equal to 25, or mean is greater than 25, or mean is less than 25. So under which business case will have like this? My questions to Yatendra, Hari, Sanjay, who all have covered this thing. Yatendra, are you there on the line? You can speak up.
Yeah, I am. Are you asking about an example we need to give?
Yeah, I'm asking about example. Yeah, I've got an answer from Sanjay. When we don't care about the direction, it will be equal to as a null hypothesis. So let's say I'm building one product. Let's say I'm building a battery. Okay, I'm building a battery, and I'm claiming that the mean life of this particular battery is 7 days. The mean life of this battery is 7 days. So my null hypothesis will become mean is equal to 7 in this case. What would be the alternate hypothesis in this case?
Not
So you
equal
got
to
my
7.
question.
Not equal to 7, and it will be both tailed. Two tail.
So you need to understand which is more harmful for me as a business, whether it is not equal to 7 or whether it is less than 7, because greater than 7 is having a no effect in my business, right? If I'm claiming something that it would stay for 7 days, and if it is getting, if the life is greater than 7, so that is not an risk for me, that is an added advantage. So what would be an ideal alternate hypothesis in this case? You need to understand, you have studied what is hypothesis, you need to frame what is null hypothesis and alternate hypothesis. So what would be the null alternate hypothesis in this case? Then Sanjay, no, the null hypothesis would be what you are mentioning, that null hypothesis would be greater than equal to 7. Okay, can you explain why the null hypothesis would be greater than equal to 7?
See, the
Okay,
what the
so
what you want ideally should be represented in the null hypothesis. So
exactly, the favorable conditions will always come in the null hypothesis, and the unfavorable condition will come into the alternate hypothesis. So here the null hypothesis will become the mean is greater than equal to 7, and alternate hypothesis will become less than equal to 7. Okay, so that is the hypothesis that we have. Okay, so let's say in this example, that suppose we want to test an hypothesis that the mean of familiarity rating exceed 4 neutral value on a 7-point scale, a significance level. The hypothesis may be mean of the, okay, so it is very similar that to what we have discussed. So you don't need to think it in a way that always null hypothesis would be something like equal to. So this is a very wrong statement, that when you find it on the Google, you will get somewhere, you'll get a difference that in the null hypothesis you always you will have you will always use a sign that is equal to, but that is not the case. Always you need to think about your problem statement. If it whatever is a favorable thing comes under the null hypothesis, whatever that is not favorable comes under the alternative hypothesis. Okay, and okay, so Divya, whether it is clear to you or not, do you have any questions on what is null hypothesis and alternate hypothesis? Okay, let me ask you a quick example where you need to frame what is your null hypothesis and what is your alternate hypothesis. Okay, uh, Okay, let's say if you have in a banking industry, let's say if a customer is, so your bad definition in a banking industry is if a customer is three cycle, if a customer is delinquent for more than 60 days, you will treat that particular customer as a bad customer. If a customer is delinquent less than 60 days, you will treat that particular customer as a good customer. Now my question is, if you want to make a model where, if you want to make a strategy where you want to target the good customer only, so what would be the null hypothesis in this case? Based on the delinquency, what would be the null hypothesis in this case? Okay, so the question is, Sanjay, uh, yeah, so okay, Sanjay, the question is, uh, if a customer is delinquent for more than 60 days, you will treat that customer as a bad customer. If a customer is not if a customer is delinquent less than 60 days, you will treat that customer as a good customer. Now you need to create an hypothesis. You need to create an hypothesis out of this. So what would be the favorable condition for this? Always favorable condition for a bank is you need to target a good customer. So your null hypothesis would be delinquency will be less than 60, less than equal to 60, exactly, and the delinquency greater than 60 would not be your favorable condition, so that become an alternate hypothesis. Okay, so now let's talk about type 1 and type 2 error. So type 1 error is something when you reject a true null hypothesis. Okay, when you reject a true null hypothesis, so there is two case where whether h naught is true or h naught is false. Okay, but from our model we have rejected h naught, which makes it as a type 1 error. Okay, type 2 error is the failure to reject the false null hypothesis. So type 1 error is also known as false positive, and type 2 error is also known as false negative. So now let's talk about the confusion matrix to discuss what is this false positive and false negative. Okay, uh, let's talk about the confusion matrix. uh, okay, let's say you have, this is your actual, this is your actual positive, uh, let's talk about good, actual good, and it is actual bad. This is your predicted good, and this is your predicted bad, and this is your predicted. Okay, okay, so what we are going to discuss is, we are going to discuss what is the type 1 and type 2 error. Before that, I quickly want to cover what is the confusion matrix, because that will make you clear understanding what the type 1 and type 2 error is. Okay, so now on the, what on the horizontal axis, I have a predicted, which means what I have predicted. So I have two types of customer. Let's say I have two types of customer. First one is good customer, and the second one is the bad customer. So this is the prediction that I have done. This is the actual that customer is. So if it is actually good and I have predicted it as a good, it means that it is true positive. It is true positive. Now If it is actually negative and I have predicted it as a negative, it is equal to true negative. Okay, what I have explained, if it is an actually positive and I have also predicted it as a positive, it means it is equal to true positive. If it is actually bad and I have also predicted it as a bad, it become true negative. Okay, now if it is actually negative, which means if it is actually bad but we have predicted it as a positive, it become false positive. You understand the thing? If it is actually bad but we have predicted it as a good, it become false positive. Let me highlight it with some color. Yeah, this become false positive. Now if it is actually good but I have predicted it as a bad, it become false negative. It has become, sorry, it become false negative. So this false positive is known as, this false positive is nothing but type 1 error, and this false negative is nothing but a type 2 error. Okay, type 2 error. So this is a two different error that you will get in a classification modeling exercise. This is the classification matrix that I have explained you, which has, if we predict, if it is actually bad and we have predicted it as good, it becomes false positive and it is equal to type 1 error. And the second case is type 2 error, when it is actually good and we have predicted it as a bad. Now a very interesting question and a very common question in an interview: which error is more uh, vulnerable, which error is more have a highest impact, type 1 error or type 2 error? So I'll start with one person first. Sanjay, can you tell me which error is more vulnerable in this case? Depend on the scenario, Sanjay. Okay, it depends on the scenario. You will never tell that okay, type 1 error is more, has an highest impact compared to type 2 error. It depends on the scenario, it depends on the business impact. Now Sanjay, can you tell me one scenario each where the type 1 error is more important than a type 2 error? Sanjay, can you tell me? Yeah, okay, banking company, let's say fraud detection, exactly. Type 2 will be important in fraud detection and type 1 is new banking company. Can you explain me what is this fraud detection? Do you have mic? Can you speak up? Okay, no issue. Yatendra, can you tell me the two
Yeah, so
scenario where this
yeah, so I'll
two
explain
different.
what Sanjay has said. So new banking company is more important that they are trying to acquire the customers. So they do not want any customer which they want to reject that customer when in that case they are trying to acquire more and more customers. So they can they would like to get if they can get a little bit of where someone is a bad customer also, they'll still try to take it. But on the other side, if one is a established bank, now they are not looking for the number of the customers here, they are more looking for the quality. And that's where the type 2 error comes, that you are trying to reject. If someone is bad, you want to reject it, you do not want to take them. So that's where those two examples are coming from.
So for the established bank, which error is more important, type 1 error or type 2 error?
Type 2 error.
So type 2 error will be more important for the established bank, because the reason is you want to have a quality of customer, right?
Correct.
You don't
So
want
yeah,
a
whoever
bad
is
customer in your book.
exactly.
So
So, but
what the
type
type 2
1
error? Yeah, you are getting wrong. So what the type
yeah.
2 error is? Type 2 error is you are you are predicting good customer as a bad. Okay. Okay, let me come to this again. Type 1 error is something where you are predicting the bad customer as a good. Okay, you are predicting a bad customer who is actually bad. You are predicting that customer as a good, which means for the established bank, when I want to have, I don't, in a banking industry, no matter when I'm doing a new banking business or an old banking business, I don't want to have a bad customer in my book. Okay, even for that, if I lose some customer, if I lose some customer, I am okay with it. So banking business works on this fundamental, that even though if you lose some good customer, that is not an issue, but you don't want to have a bad customer in your book. Okay, which means that I need to predict my bad customer in a proper way. So type 1 error is when I have failed to predict my bad customer. My bad customer, the proportion of bad customer, I have predicted it as a good, which is something that type 1 error is. So in that case, type 1 error becomes more important for the established bank, or you can say that a banking business where we are not focusing on the acquisition, we are only focusing on that we want a good bad we don't want a bad customer. We are okay to lose some good customer, but we don't want a bad customer. So Yatin, that you what you have speak, you have just confused with type 1 and type 2 error, right?
Yeah, correct. Sorry. Yeah, I just mixed it up. Yeah.
Now can you think about example where the type 2 error become more important? Health management. Arav, can you explain this? So don't have the mic. Okay, no issue. Yeah, exactly. In the medical industries, okay, in the medical industries, when the customer is having is don't have that disease, and you have predicted that this particular customer has this disease, and you do the treatment that to that particular customer, that is not, that is again, in that case also the type 1 error is more important, because you don't want to miss the customer who has that particular disease. Okay, in the health manager or management or the cancer detection, you don't want to miss that particular customer who has that particular disease. Okay, so one of the example that Yatendra has mentioned, that new banking industries, okay, where you are going where you want to acquire a customer, if you think it in a more practical way, that is not the case. Even if you open a new banking industry, you don't want to have a bad customer in your book. Okay, in that case also
No,
you want only to have a good customer
what
in
we
your
were
book.
saying is that you will have a more lenient threshold in that case. Like you're trying to, you won't be as strict as an established
Exactly,
bank,
exactly.
and
Yeah,
your
yeah, yeah.
threshold will
That
be
makes sense.
more or less. Yeah.
Yeah, but when you talk about the banking industry now, you always need to think it that you don't want a bad customer. Even though you, if you lose some good customer, that is okay. But in a banking industry, you don't want to have a bad customer. The reason for this is very simple, because in a banking industry you're not producing something, you are using a money of that particular country. If you're running a bank in a country, you are using a money of that particular country. So you always try any of the credit risk modeling and anything that you build in a financial industry, you'll always focus on a type 1 error. You'll never think about the type 2 error. Okay. An actual innocent guy predicted as criminal. So okay, I will leave this to you to think about the scenario where the type 2 error is more has a higher weightage than a type 1 error. Okay. Okay. So I think you have understand what is type 1 error, type 2 error. Yatin, do you have studied about the classification matrix in your session with Srikanth?
Yeah, we did.
Okay, so what is, you know, the formula for sensitivity, specificity, all this thing?
Yeah, it was given to us. I think we need to revise again, but yeah, we know of those ones.
So I really want to understand, this is like you're doing it for the second time, or then why this session is there in the schedule?
No, he did the statistics, but the intention was to continue to machine learning, with Python, which you are doing now. So he had covered a little bit of statistics before.
Okay, 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 okay.
Yeah, so you are
I
continuing
think,
from there. Yeah.
okay, theory was covered more. Okay, so all the theory for the regression, logistic regression, all these things are also covered.
Yeah, some of it, we did in Excel and all that. We did like a logistic regression and simple regression and all that. We did some exercises in Excel only, but it was built towards doing it in the Python, which we had not done. I think that's where you came in to actually start showing that, and we need to go towards the Python, machine learning.
Okay, okay. Okay, so because the inferential statistic, what I have understand that the inferential statistic is something where you need to have more theoretical concept, and I was not knowing this, that you some of you have already had the discussion with Srikanth. So that's why I had tried to make it a very basic so that everyone can understand what is the theoretical concept behind inferential statistic, because there is nothing more to show this inferential statistic in the Python, right? So that is why in the today's session you have seen that we have not used the Python after first hour. Okay,
We
because
have been in different sort of batches. Not all of us has been in the same batch, so that's where some of us may have covered some theoretical from Shrikant, others may not have. So that's why I think it's from your side, it's
okay,
good
okay, okay.
that you are showing
Then it's
everything.
good. Then I think it's good to have this session. I was thinking that okay, if you guys have done this, then I'm just doing the revision of for you guys. Okay, so I think we are done with the hypothesis testing. That is the second last topic of this session. We have discussed what is type 1, type 2 error. We have also discussed the intensity of the type 1 and type 2 error is different depending on the different business scenario that we have. Okay, I will send this PPT. I will keep this PPT in the drive soon after the class. You just go through this PPT. This is just a quick revision that you will get for the all the inferential statistic that we have studied. This is a much detailed PPT. I think I have digged 10 15 PPTs to make this PPT. So this is very good information that you will get from for all the quick revision for all the inferential statistic concept that we have discussed. Okay, and do you, if you have any doubt in this, we can discuss this in the next session. If you have any doubt in this, we can have the discussion. Okay, so last topic that we are going to cover is covariance and correlation. Soon after this, we'll have a doubt session. If you have anything to discuss from the previous session, any exercise that you have done and any question that you are facing, any issues, we'll discuss that, and then we'll wrap up the session. So can you tell me what is covariance and correlation? We always used to come across these two things, correlation and covariance. Okay, so let's me start with this. Till now what we are doing is we are doing the statistic of one variable, but in an actual scenario we'll always have to think a relation between a two different variable. So from there the concept of correlation and covariance come into the picture. Okay, so what the covariance and correlation look like? Let's say I have a two different variable x and y. The first one is cigarette and the second one is the lung capacity. Okay, so this is the two variable that I have. When you plot this variable, when you do a scatter plot of this variable, you get this picture, right? uh, on the x-axis you have a smoking and on y-axis you have a lung capacity. Now what is the inference that you are getting from this picture?
So more you smoke, lung capacity, is reducing.
Yeah, so the number, if you're smoking more the lung capacity is decreasing, if you're smoking less the lung capacity is higher. Okay, so it means that there is a negative
Negative correlation.
correlation. So now when we what is covariance and correlation comes into the picture over here is we can see easily from the graph that the smoking goes up, lung capacity tends to go down. The two variable co-vary in the opposite direction. Okay, so to understand the direction, so when we talk about the relation between the two particular variable, the two things come into the picture. First one is in which direction the relation is there. First thing is in which direction the relation is there, and the second thing is to what extent the variation of this particular variable is explained by that particular variable. When we talk about the two relation between the two variable, what we need to understand is first of all we want to find the direction in which these two variable co-varies. To calculate the direction we have a covariance. So covariance will normally tells you that, so the significance that we used to get when we are doing a modeling from the covariance number is the direction of the flow of this two particular variable. Okay, and the from the correlation what we used to get, we from the correlation we used to get how much extent of the variation is explained by the other variable. Is it clear? So when you plot a correlation matrix, you will not get a direction of the variance. To get a direction, you need to plot a covariance. So, and how we are going to do plot a covariance and correlation, that we have already discussed in the Python. That okay, yeah. So this is what we have plot. This is the correlation matrix that we have got, and this is the covariance that we have got. Right. So normally what we have is covariance is normally used to give you a direction and correlation is normally used to give you a extent to which this variance of this particular variable is explained by that particular variable.
Yeah, the strength of the relationship.
Yeah, also you can get both the thing in the correlation also, because correlation is something, the formula of correlation is equal to covariance divided by standard deviation of x and standard deviation of y. So ideally you will not use covariance in any of the case, because the information that covariance contains you will easily get it from the correlation also. The information that covariance content is a direction, whether it is a negative or positive, that you will get from the covariance correlation also. Okay, so we'll in a general practice will not use covariance as much as we use correlation because it has both the information, and normally correlation is also derived from the covariance divided by covariance of x and y divided by standard deviation of x and standard deviation of y. Okay, so let's say, well, we are calculating a covariance, the formula of covariance is uh, we need to take a we need to take the summation of that particular variable with the mean xi minus x, which is mean, into yi minus y, which is mean of y. So x, I have calculated a dx change in x with respect to mean, again y, and we have multiplied dx by dx and dy simply. So what I have done is, for x, I have calculated the mean of this x and I have find this minus mean. So the mean of this x is, when you calculate the mean of this, it will be 10. Okay, 15, 5, 20, 20, 30, 40, 50. 50 divided by 5, mean is 10. Then 0 minus 10 is equal to minus 10. 5 minus 10 is equal to minus 5. 10 minus 5 is equal to 10. So this is the mean of this x. Hello, am I audible now? Yes. Okay. Okay. So actually, my connection got lost. Okay. So okay. So I think we have covered pretty much of the today's class. We have covered all the things that come under the inferential statistic. The last thing that we are covering is correlation and covariance. We have also discussed what is the importance of covariance and correlations. So now from the tomorrow's class, what we will do is we'll start with the regression first. Since I will not touch most of the theory part of the regression. We'll take an example. We'll do it in the Python, how we do the regression in the Python, and we try to infer the result from the Python. We'll somehow we'll quickly discuss what are the assumptions is. Second thing, I would request you to do all the exercise, and if you have any doubt, you can tell us. We can discuss that doubt, and that's all from pretty much from my side. Do you have any doubt from the previous exercise that I have given to you? We can discuss. We have 10 minutes. We can discuss the doubt that you have. Anything you want to discuss? Any conceptual thing? Anything that you are not there in in the session, that you have missed the session? You quickly want to revise. You quickly want to understand anything? Yeah. Okay, Yatendra. So others, can you do you have anything to discuss? Any questions? Yatendra, have you tried that mean median mode that I have explained you yesterday? So have you tried to find how we will calculate mode without using a functions?
No, mode not yet. That I will try. I'll take it as a homework. Yeah, I'll try it. I want to try it out.
Okay, and also you can also try one more question is, you want to sort a list without using any function.
Okay. Okay,
Okay,
sure.
how to sort a list without using any function. So I request you all to do the practice, otherwise you will not come up with the doubts. Right. So please try this question also, Yatendra. You need to sort a list without using a sort function. Right? Can
Yeah,
we do
yeah,
that?
sure. We can. Yeah, we can do that, and we can discuss that as a first thing next time.
Yeah. So because I want in the last 10-15 minutes of the session that to discuss the doubt that you have. And if you don't have any doubt, we'll just waste this 10-15 minutes of our session. Any kind of doubt, any small doubt, anything that you want to discuss. Divya, Sanjay, Soubik, Vakar, Yatendra, Arav, anything that you want to discuss. Anything you want to discuss, we can talk about more tasks like modes or sort. Yeah, Sanjay. So I have given you this two thing. You can do this, and we can talk about this two tasks. This is very important. This is this kind of questions that you will get in an interview of an analytics company, and this will improve your coding skills also. Okay, Sanjay, you have tried that sort. Okay, good. Okay, so I think we have done with the basic Pythons, all the NumPy, pandas, all the descriptive statistic dealing with the missing values and the plot. Now next from the next class, next week in class, in each class we'll discuss an ML techniques, one ML technique. So in that first 30 or 40 minutes, I will be mainly talking about what are the assumptions, what are the theoretical concept behind that particular techniques, and then we'll have an example and we'll solve that questions in the class, and then we'll try to infer the result, and we'll try to improve the result. So let's say if I have a data set, I will make a regression, I will get a result. Now we need to think that how better we'll get out of that particular data, how we can improve the predictive power of the model that we developed. Okay, so that is from the next class we'll have. And please try to come up with some of the doubt that you have. We'll discuss this in the last 10-15 minutes of the class, any kind of doubt. And please try this two questions. First one is the mode, and the second one is the how to sort a number without using a function. You have to sort a list. You need to create a list. You need to sort that list without using any function. Okay, and also map and apply functions. We have discussed what is the difference between map and apply. Okay, also, okay, that's all from my side. Anything you want to discuss, or we can wrap up the call? Okay, then thank you all for attending. Thank you. We'll start the machine learning from the next week. Okay, thank you. Bye. Have a good week.